Okay. Here we go. All right, so everybody's paying attention. This is an easy problem. We're going to solve this guy. I already distributed, looks like. So 3x minus 1, 5x plus 6. Let's get all these x's on the same side. Keep an eye on me now. Did I do that part right? Okay. Now I'm going to divide by -2. And when I divide, I'm going to make sure that I switch my sign. I only do that if I am multiplying or dividing by a negative. And I am dividing by a negative. So what's my answer? Let's write it as an interval. What interval would that be? Think about what it looks like on the number line. So what interval would that be? Bracket, -7/2, comma infinity. All right. What's going to be your strategy for the next one? We have several options, but what would be your favorite? Common denominator? So what would the common denominator be? 12. So if we make all the denominators 12, so we're going to multiply this one by 4, this one by 6, this one by 3, and this one by 4, all my denominators are now 12. And as soon as that happens, we can forget about them. So 4x plus 6, 3x plus 4. And I'm not really just erasing them, I'm multiplying everything by 12. And that would be what it does. So, how does that? Is that what you got? Is that right? So what would be my interval? What my interval look like? Yeah, Robert?
Parentheses -2, comma infinity.
What are the rest of the things? See, right? Yeah, and that's where we're going to get in the habit of writing our answers because we are soon to be calculus students. So we're going to use that kind of notation. All right, how about this guy? Any thought about this? I know these are all review. I find them a little bit boring. I do them anyway. How do I solve something like this? Multiply everything by 3. Okay, so -9, that's everything, you guys. So left side times 3, middle times 3, right side times 3. Now we're solving for x, so maybe subtract 5. And again, it's a 3-part problem. Left When you get them done, go ahead and put them up on the board. Alright, I don't have any volunteers up here. Anybody got these done? But if you don't volunteer, you just have to listen to me. Oh, yeah.
Let's go back to this process.
Okay. F, anybody do F? He got, this is equals, he got -5/7. Okay, Karen's nodding. Okay, so the common denominator here was 12. So when he multiplied, I would have needed to, that worked out great. Good with F? E is a little bit different. I started out by timesing everything by 7. Does that make sense to you if I multiply everything by 7? Now, here's the deal. I would love to be able to get that x by itself in the middle of the problem, but it isn't going to be possible. So, I have to recognize that this thing really says two things. It says this, and it says this. In other words, 5x plus 1 has to be bigger than negative 21x plus 14 plus 14x. But 5x plus 1 also has to be less than this. So I split it up into those two statements. Does that step make sense to you? Alright, so then I solved each one. This is where I'm not sure. I hope I kept things straight. I got x less than 22/9 over here. And that's critical because that guy has to be bigger than this and less than this. So that's an important word. And then I solve this one, and if I get it right, I got this. How does that look? Does that look better? So now I have to get an answer on all that. Okay, so let's look at our situation. I don't know, 22/9 is 2 point something. So I'm gonna put 22/9 out here. And I have to be less than that. Okay? And then 36/37 is less than 1, so it's over here somewhere. And I have to be greater than that. But I have to be both. I have to be this, think of it as blue and pink. My answer has to be blue and pink. So what's the answer at? In between those two, yep. And everything's open. So 36/37, comma, 22/9. How does that feel? Does that feel okay? If you were a little confused by that originally, are you okay with it now? Good? Alright, last one. And then we will go into our calculator. So go ahead and solve this one. I think you can. We've already done a couple like it. I'm not sure. Do you have another one? But go ahead and solve that. Let's see if we can come up with the same answer. because you will definitely develop a preference on how you want to do it, and it doesn't matter. So we'll do it both ways this year already. So let's just, for fun, set a standard window so that we're all looking at the same thing. So if you go to window, the button that says window, and you press Zoom 6, it will give you what we call the standard window. Negative 10 to 10, negative 10 to 10. So we're all looking at the same thing. Okay, now let's go to y equals. And let's put in each side of the equation as a separate thing. So y equals, we're typing in x squared. X, remember, do you remember your variable button right there? That's your variable button, that's where you get your x. So you're gonna press x squared minus 2x. And then for y sub 2, let's put in 3. So we're putting in the left side is one equation, the right side is the other equation. And then let's press graph. And you have parabola and a line. And they're clearly crossing each other, right? So remember, this is our parabola. So it looks something like this. And then the line's coming through. This is where they cross. That's where they cross. And I want the parabola to be under the line. So this is actually the solution to the problem. Would you agree with that? So I need to find that point and that point. Do you remember how to find this one first? You know, you one at a time. Do you remember how to find that? Second calc or second trace. Calc then you. Second trace. We want to know where they intersect, so we're going to click down watch him. We're going to click down to intersect. If you don't have a calculator, look at your neighbors. Come on. Press intersect. Yep. Put your seat back. Watch out. Got it. Remember the whole first curve, second curve thing? What is this point of intersection right here? What is that? Negative 1, comma 3. Now remember, we are solving for x. So this is what we're interested in. That x value is negative 1. Alright, let's do the other one. Start over again. Second trace or second calc, intersect. If you don't know how to do that, what did you get for that one? 3. So again, we're solving for x. So we're interested in the x coordinates. So if this x is negative 1, and this x is 3, and I want all the x's in between, then my answer will be this. Right, that interval. Open dots, because of that, that goes in. Alright? Let's take 2 minutes. If you don't have a calculator today, or if you don't know how to do this, go find somebody that will step you through it, or let you borrow their calculator for a minute. 2 minutes, go. Go. There's somebody in this room that doesn't know how to do that. We're going to figure it out right now. This way that we just did is called the intersection method, because we drew two curves and looked at where they intersected. You can also move everything to one side and graph only one equation. So here, I would graph this equation. All right, so I'm going to do that. Again, either way is fine. You do not have to do it one way or the other. I'm just going to clear those out. That whole equation. If I do it this way, okay, so I get my parabola again. If I do it this way, there's nothing to intersect. So I'm not going to second calc intersect. I am going to second calc 0 because I want to know where this thing equals 0. So second calc 0. And then I do the whole left bound, right bound thing. And lo and behold, that x-coordinate's -1. Do it again on the other side. And this one is a positive. It's a less than, so we're looking at all the x's underneath those dots. So we get exactly the same answer. All right, you and your partner try the next one. Do it any way you want. Each of you do it a different way. I don't care. And let's see what we come up with for problem 8.
Yeah.
Anybody that doesn't know what's going on, come up and watch me press buttons if you want to. Something we haven't talked about in AP calculus, we round to at least 3 digits, okay? Thousandth place, 3 digits. So, keep that in mind.
Someone else.
I don't know why it's on.
It's your alarm.
Okay,
Sorry.
so I did intersections. Now, I don't know if you know, I don't know, anybody else do intersections? if you did intersections, that point was off my screen, so I had to change my window to get that point on there. So anyhow, this is what I got. My points of intersection were negative 0.193 and 5.193. Do those sound familiar to you? Is that what you got for your X's? Now, you gotta answer the question. If you did it with intersections, you want the parabola to be above the line. So isn't this and this where that happens? So what is my answer? Not in between those two numbers. My answer is negative infinity to negative 0.193. Since that's an or equal to, these are actually closed dots. So there's the first half of my answer. And then the other half is 0.593 to now, no matter how you did it, that's what you should come up with. So, did anybody come up with that? Am I on the right track here? We're good? Perfect. 5A could have been done without a graphing calculator. That's a fact level problem. We could have done it relatively easily. 5B is not quite so easy. 5B would be hard to do without a calculator because the roots of the parabola are imaginary, and so you would be able to graph that. So, okay. All right, here we go. Part B, solve for the indicated variable. All right, so we don't need a calculator for this. We are going to take the formula. Anybody know what this formula is for? What is this? What? Trapezoid. That's the area of a trapezoid. And we're going to, instead of solving for A, we're going to solve for H. So that means whatever you're doing, eventually get H equals. Okay, so what do you want to do first here? We're going to do that H by itself. I don't know, I'm going to times by 2, because I want to get rid of that fraction. This is easy. If I'm solving for H, all I need to do is divide by the parentheses, right? So I'm going to have 2A over the sum of 1 and 2. Is that all right? B. See if you can solve for R. What's the formula in B? What is that one? Volume of a sphere. I'm going to get R by itself. So go ahead and give that a shot. Let's see what you come up with. I multiply by 3 to get rid of the fraction. Divided by 4 pi. Believe it or not, that's a skill, taking a given formula and solving for one of the variables that you don't normally solve for. You're going to do that a lot in calculus class because you're going to then take this right here and plug it into another formula and then do something, find a derivative or something. But you do that a lot, that's kind of substitution. Okay, let's get some vocabulary under control. school. P3 is due on Friday. P4, here we go. What's the slope of a line? Remember, after P5, we'll have quiz. So P4, what's the formula for the slope of a line? Charlie?
Y2 minus Y1 over X2 minus X.
Y minus Y over X minus X. And it doesn't necessarily, oops. Did I get the wrong paper? Yeah. I'm sorry. When we say y minus y over x minus x, it doesn't really matter what order you go, but you have to go the same order both times. So if you go 0.2 minus 0.1 for the y's, you have to do 2 minus 1 for the x's, right? Point slope form of a line, what's that look like? Who knows? Point slope form of a line. You guys had a Mrs. Ludington. You did point slope form of a line, because that's like her favorite. Patrick?
Y2 minus Y1 equals slope times X minus
How that like manifests itself is, let's say we have a slope of 5, which is an easy number, and we have a point that's negative 1, 4. You simply take y minus 4. I really don't like those subscripts too much, but it's okay. You take y minus 4 equal to 5 times x plus 1. So y minus y coordinate equals the slope times x minus the x coordinate. That's what the point slope form of a line looks like. How about the slope intercept form of a line? What does that look like? Y equals mx plus b. How about the standard form of a line? What does that look like? The standard form. Ax plus by equals c. We don't like to graph them like that usually, but you see them a lot. That kind of thing, that's the called the standard form of a line. What does a vertical line look like? A line that's vertical. What does that look like? X equals something, right? X equals something. Remember guys, a vertical line is going to intersect the x-axis, right? So it's x equals. A horizontal line is going to intersect the y-axis, and so it is y equals something. What's an x-intercept? Something, comma, 0. It's on the x-axis. So any point on the x-axis is going to be something, comma, 0. And any point on the y-axis is called a y-intercept, and it is going to be something, comma, y. Right? 0, comma, something, 0, comma, y. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal. So opposite reciprocal. So perpendicular lines. All right, we'll stop there. We'll pick up there tomorrow. You're going to period, I don't know, what's next? 5? 3? No, I don't think it's 3. Is it 3 or is it 5? I think it's 5. I think it's 5 today.